exercises में से हो रहे हैं सब तकरीबन, ये सारे ही सवाल आते हैं। बात तो होती है कि कोई सवाल नहीं हो, जब सब समझ आ रहा है और कुछ समझ नहीं आ रहा। दो ही एक्सपेक्टेशंस हैं। Let's move ahead. So, what we were doing last time. Started discussing the closure of a set with some examples, and so what was the definition of a closure? So if we say that E is a subset of a metric space X, we're going to say that E is closed if and only if, and only if, but E is closed if E is equal to E union, set of all limit points, accumulation points, whatever you call it. So that was, kind of that definition. And then we did some examples for that. There are a number of ways to define basically. When this E closure is going to be equal to E union E, sort of all limit points. So it's like you have set E in the metric space X. Okay, so you have set E. Okay. And if you include all of its limit point into it, okay, then you call that thing as what you have the closure. And we did some examples. Not getting into it again, so I would like to directly get into some of the properties of the closure, and that's our key result. Next thing. So one of the interesting properties of the closure is that if E is a subset of metric space X, then this set closure is basically a closed set. Okay. And what we mean by a closed set? What is the definition of a closed set? So it contains all of its limit points. Okay. And then we'll have an excellent characterization of closed sets and how you can immediately recognize whether some set is a closed set or not is basically this, that if you compute the closure of some set and it turns out to be equal to itself. Okay? So it's like, so when this will happen actually, just think about it. If and only if E is closed. So if E is closed, then then its closure is going to be, same. In other words, it's going to contain all of its limit point. And if this is true, then your set E is closed as well. And the third beautiful property that this closure has is that it's it's a smallest closed set. So it's like if I say closure of E is the smallest, okay, inverted commas, closed set. Will define what I mean by smallest closed set, containing E. Containing E. So in other words, if you are computing a closure of a set, you are basically determining the smallest closed set which contains that set. So, in other words, you can say that if E is contained in F, so if E is a subset of F, and F is a closed set, then the closure of E must be contained in F. Okay? I mean, if you see, it's really analogous to what you have, the least upper bound. It's like a least upper bound. Okay, it's upper bound. Okay. It's not obviously not like there is some analogy. You can see at least that okay, there is similarity. The way we have defined it. So if there is a closed set which contains E, then the closure of E must be included in F because the closure of E is the smallest closed set which is contained in F. And this is going to show basically like that. So what I would like to do is to go through a quick proof of this, or at least idea of proof of this theorem, okay, because this is going to help us a lot afterwards. For practical purposes, this is also something very useful when you try to basically compute the closed sets. And this property is good. We're going to see that it turns out to be a very important property afterwards. When you want to drive some of very complicated results, actually, or prove some of very complicated results. So let's think about a proof of this. So imagine I have. So I'm making a fictitious picture. Don't treat that picture as kind of something very concrete. So I'm just making a. So that's your metric space, okay? And you have a set E here. You have a set E here. I don't know how does it look like, but something like that, okay? And then you have another set which is which contains E, and I'm kind of naming it as. So E closure. It's a closed set which contains what? E. Okay. And I want to prove that this closed set is no. The first thing that I would like to show that it's a closed set. It's a closed set. So how should I begin? How we can prove, or how we can know actually that something is closed. Yeah, sure.
You can be contrary because
how you can do it through distance? Can you describe it
जैसे
more precisely?
हम एक पॉइंट लें ई सेट से और जो ना उसकी क्लोजर नहीं उसकी बाउंड्री पॉइंट से ई बोले और उसका डिस्टेंस है ई से तो वो 0 है.
We haven't defined boundary, so I'm not going to deal here with the notion of boundary. So we just talk about limit points. So it's like there are two ways at the moment so far we have learned. Number one is to directly verify the definition. That okay, you have a set which contains all of its limit points. In other words, you take a limit point of the set and prove that this limit point must be in the set actually. So that's one way. The other way is going to be that if you want to prove that this E bar is a closed set, take its complement and try to prove that complement is open. Okay. So we can do both way. I can go one way, and you may think about the other way as well. Okay, it's worth exploring actually. So what I need to do pictorially, in order to prove that everything else than this E closure is open, what should I do?
Take a point and make a
Let's take a point basically. Where should I take a point? Okay, let's try to take a point maybe here. Okay, that's a point, in the space E. Then
take its neighborhood and show it is in its complement.
Then we need to find a radius actually.
Yes, sir.
Okay? We need to find a radius, or we need to find a neighborhood, okay, on this ball which is entirely contained in.
The complement of E bar.
So how can I find that radius? What do you think that what should we do? What should be? How can I make sure that such an R exists, and with such an R, if you can draw a circle around it,
It's entirely
it's going to entirely contained in.
E
What do you think that?
E bar देख लो उसको.
हमने वो पढ़ा है कि पॉइंट सेट का डिस्टेंस यूज कर सकते
Point cut.
पॉइंट सेट का डिस्टेंस
Say infimum distance from this point. We
How
use
do you find it?
No.
And try to come up with something which is not. But one of the key information which is given to me is that this point is outside E bar, and E bar is union of two objects. So it's like it's in E and it's E prime actually. Okay. So if P is not in E bar, that means
it is not in both.
it's not in both actually. So neither P is in E, which which shows actually like that, nor P is a limit point of E actually. So if P is not a limit point of E, what does it mean? Okay, it doesn't belong to E prime, but what does it mean? When something, some point which is not in E is going to be a limit point of E. So just negate that. So, what's the definition of being limit point?
There exists a neighborhood such that intersection is
Is it the definition of neighborhood? Or is it the definition of being limit point? So limit point is that, a point is a limit point. If you draw any ball around it, it's going to intersect with or meet with the set actually E. So in other words, if we are saying that I have picked a point from E closure complement, so it's not in E and not in E prime, and it's not a limit point, that means that there must be
One
a radius,
one radius.
at least one radius, so you got the existence of radius. Okay, there must be a radius that if you draw a ball of that radius, okay, on P, it's not going to intersect with E actually,
Yes, sir.
okay, but it may intersect with E closure. Either. So our claim is that, the radius that is going to basically, that is, we are getting radius as a result that P is not in E prime, okay, is not a limit point of E, that with that radius, this ball is not going to intersect not only with E, but is not also going to intersect with E bar actually. Okay? Because if we have this, what's going to happen? So my claim is this, that this ball is not going to intersect with E bar either. In other words, it's going to be entirely contained in E bar complement, and hence the E bar complement is going to be open actually. So I want, before writing, I want to think about that why this ball, which is not intersecting with E, should not also intersect with E bar.
Sir,
Can
assume
you see a pictorial? Can you see some reason pictorially? Okay, we can, when we start writing a proof, we can find proof that not a big deal. But can you see pictorially that what is going to be the trouble if you kind of take this neighborhood and intersect with E bar?
it's going to be limit point of E bar.
It's going to be
Limit point of E bar. So E bar is And all points of E bar must be in. It's going to.
So that's what we want to prove actually. That all points of E bar are, all limit points of E bar should be in E bar. Anyway, so let's keep this picture in mind. So let's think about this first part. So we are saying that let P is a point in E closure complement. Help me. Okay?
Yes, sir.
So if it's a point in E complement, so P is either in E
No.
or in
Limit point.
P is a limit point. So if P is not a limit point of E prime, so that is P is not a limit point of E. Limit point of E. Okay? So if it is not a limit point of E, then so we can find a radius, some positive radius, such that if you take that point and draw a neighborhood of this radius on P, which is this actually, is going to have an empty intersection with
E.
E. Okay? So my claim is that the same neighborhood is not going to even intersect with E closure. Okay? So claim is that N out of P intersection closure of E is also empty. Okay? Because if this happens, what does it mean? It means that this is a subset of E closure complement, and that's what we want actually. That's what
Yes,
we
sir.
want. Okay? So what do you think that how should we proceed and prove basically this part? That
Suppose
what should be our way to do it?
Suppose contrary related.
Okay? So one of the way would be that, okay, suppose the opposite. Suppose that there is an element in the intersection of both. We're going to show, or we can see that that element is going to be something very troublemaking actually. Okay? So suppose not. Okay? Suppose not. Or maybe suppose that this neighborhood around P meets with, it's not meeting with E, but it meets with E closure actually. It meets with E closure. That's what it means actually. Okay? So what does it mean? So if something meets with E closure,
एक ऐसा पॉइंट है जो कि नेबरहुड में भी है और एक
okay? So this means that there exists a Y in this N out of P and E closure, which is, so there exists a Y in both. So take a minute and take some seconds and think about that, why this Y should be a troublemaking thing. We know that intersection of neighborhood on E does not meet with E actually.
सर और यहाँ
But is it necessary that?
यहाँ से तो बाय ई में भी जा रहा है क्लोज में
It's not-
सर जब हम कहेंगे y belongs to E closure
Uh-huh.
means y is a point in E closure
I mean, if it's a point in E closure,
E bar,
is
E
it
bar.
necessary that it should be in?
सर नो सर यहाँ ई बार है तो जा रहा है ना
Okay, so let help me out. What should I say?
y y belongs to this end
So Y must be in this neighborhood.
and
Okay, Y must be in this neighborhood. That is that the distance between E and Y is smaller than R, okay? And Y must be in E closure, which is the union of E and E prime. So in other words, either Y is in E, Y is a limit point. So if Y is in E, why is troublemaking?
Because E is a
Because Y is here also. But we just said that, you know, they don't have anything in common. So how you can have something, you know, which is common and both actually if they're empty. If they're disjoint, okay? So that's one possibility. So Y is in closure, it may be in E, or it may be in E prime actually. Okay? So if it is not in E,
if it is an E prime, what is the trouble?
so let's think about that, you know. So it's like if we're gonna say that if Y is in E, then this is a contradiction.
Yes, sir.
That's a contradiction. Okay, I'm not writing contradiction to what, but you can see actually that it's contradiction to this fact. So Y, you know, can be in limit prime, or it can be a limit point. So why this is also a contradictory thing? So why do you think that? Why this is something which is?
तो P भी हो जाएगा,
Huh?
तो P भी से लिमिट पर हो जाएगा इसका, अगर Y ऐसे,
If Y is a limit point, then why the P should be limit point?
लिमिट पॉइंट आउट ऑफ E भी हो सकता है.
So in other words, where is Y actually? So let me place Y somewhere. So where should I put Y actually?
That circle.
Okay, maybe put it here actually. So it's not in E,
Maybe.
okay, but it's other than basically that actually. And if it is a limit point,
Then
if Y is a limit point, what trouble it would have? You know, why cannot be a limit point also?
Sir, I neighborhood of TV भी
Sir, अगर Y
Okay, so let's put it here.
कहाँ पे भी हो सकता है पूरी मीट्रिक्स को, कहाँ पे भी हो
So
सकता है.
that's what huh?
So they say that
Uh-huh.
you're good to go then.
Sir, why
You are
is
good
there
to go.
point हो गई तो उसका neighborhood उसकी intersection E से
So what we're gonna have? So if we treat Y as a limit point of, you know, E as well, then if I draw a ball on E, it should meet with
E.
I guess it should meet with it. So if it is meeting with it, what's wrong with it?
P भी लिमिट पर हो जाएगा.
How P can be limit point then? Because that's why this guy is P. So what if Y is interacting with it? What's wrong with it?
Sir, Y की intersection जो P के around ball है उसके साथ भी तो non empty है और E के साथ भी non empty है.
सर अगर y e प्राइम में है तो वो लिमिट पॉइंट हो जाएगा e का, क्योंकि e प्राइम is the set of all limit points of e. So if y is in e prime, then y is the limit point of e, and that should give us some trouble.
That's what we are writing actually.
फिर वो आउट ऑफ E भी हो सकता है, इनसाइड E, इसलिए बस.
So Waleed reached to this point now. so thank God he reached. You're already blessed. So what? So
B direction में.
So can't you have an intermediary set between two disjoint set? What's wrong with it?
हो सकता है.
No, I mean two sets are disjoint, but you have something in common with them. So
A B C.
we'll point to this factor.
सर ऐसा नहीं होगा कि Y लिमिट पॉइंट हो जाएगी E की B और इसके कॉम्प्लीमेंट होगी.
Y is going to be the limit point of E and its
कॉम्प्लीमेंट
complement both.
बाउंड्री को क्रॉस करिए.
क्योंकि इसके अराउंड जब हम गोल ड्रॉ कर रहे हैं इसकी इंटरसेक्शन E के साथ नॉन एम्प्टी है.
सर यहाँ एक और ये ले सकते हैं ना कि y अगर लिमिट पॉइंट है, जैसे उसने कहा वो e का लिमिट पॉइंट है, या तो e के अंदर होगा या तो आउट ऑफ e। अगर e के अंदर है तो फिर वही सेम कंट्राडिक्शन रहेगी, अगर e से बाहर है तो उसके लिए सिर्फ सोच रहे हैं ना।
That's what I'm saying that.
तो मैंने बहुत
That's what the trouble is. That, okay, let's think about, especially that case that when y is a limit point of e, y. Now, I'm not going to give you this point. Okay. At least you have to think about that for yourself. Think about it. Give me that point. How about treating that as a quiz?
treating that is the
Treating this as a quiz actually.
हमारा माइंड डिस्टर्ब हो जाता है।
Thank you. Let's not stop the mind, okay? Let's think about it. Just take some minutes, take a minute and think about it. That it's something really tiny actually that we all are missing out. Just think about it. That's what it should be. Isn't that picture is telling you something? Try to come up with a contradiction. Obviously, you have to come up with a contradiction.
ये तो कुछ नहीं क्लोजर
Obviously,
No, sir.
it's not closure.
Sir.
but
there is, we can draw a neighborhood in that intersection, and that is outside E. So this makes that y cannot be the limit point of E.
Right?
No, but it intersects. We say y is the limit point of E, but we can draw a circle
So
within
you
that
want
intersection.
to draw a ball in this
Yes, sir.
intersection, huh?
Yes, sir. So we find radius that makes sure that y is not a limit point of E.
क्योंकि नेबरहुड हमेशा ओपन होता है।
So you want to draw a ball on y, okay, and of certain radius. So you might choose a minimum of 2 radiuses,
Yes, sir.
are in such a way that so what's wrong with it?
So
You found a neighborhood of y
intersection
whose intersection
is
of
empty
E is empty नहीं होगा. Yes,
होगा
empty.
E से नहीं होता।
Yes, sir. Whose intersection with E is empty, hence y is not the limit point of E. Intersection limit point. अगर आप वो तो जाओगे ना बट्टा से है लिमिट पॉइंट है.
सर y की intersection
लिमिट पॉइंट ना तो किसी भी जगह को रेडियस एग्जिस्ट करे तो हमारे वर्ड हो गया. हाँ
y is intersection.
तो समझे यू
He's saying
E से
you
स्टार्ट
need to justify.
वो तो है.
तो ये जो बॉल है हमने P के अराउंड ड्रॉ किया है, ये y के अराउंड
Why go? This ball is this small ball is around y.
पॉइंट मैंने
सर
देखी.
ये तो empty है ना intersection तो फिर ये नहीं हुआ
Give me that concrete radius. I want to write. Give me the concrete radius that you think that.
नेबरहुड ओपन होता है तो इसका हर पॉइंट इंटीरियर पॉइंट होता है तो अगर y नेबरहुड में से है तो एक बॉल ड्रॉ कर
y
सकते
belongs
हैं।
to neighborhood and y belongs.
अब वो
Neighborhood में
बॉल
अपना
इसके साथ इसका इंटरसेक्शन ई प्राइम के साथ ना empty है
सर
तो ये वाला डिफरेंस
we have got to somehow.
But Zainab is also giving a good point.
Okay, sir.
Zainab, repeat.
Give
Sorry.
Zainab. Yes, maybe it's the same one.
She can tell afterwards. Okay, tell what you have got.
Sir, actually, when we said y belongs to this E prime, it means either y is an E or y is the limit point of E and outside of E.
There is no way that it could be in E. So
Okay,
it's a
fine.
limit point,
It's okay, fine. Now, when it is it is outside E, then is above we have written y belongs to neighborhood of P.
Uh-huh.
So neighborhood of P is always open.